Hello students, welcome back to the class 10 physics subject, and in this section we are going to discuss about moment of force or torque. Okay, so in the previous section we are discussed about the translational motion and rotational motion, isn't it, of rigid bodies. So in the case of rotational motion we have said that if the rigid body is pivotal one or fixed at a particular point, when on the application of an external force, it will make a rotation around that particular point of fixed point or that pivotal point, isn't it? So in that basis we are going to discuss this particular term, that moment of force or torque. Moment of force or torque is a turning effect of the applied force on that particular body, which means when you are applying a particular force on a fixed body, it will make some type of turning in around that particular fixed point or axis, and that effect is known as moment of force or torque. Clear? For an example, just consider the case of a door. When you open a door and when you're closing the door, okay, so you are applying a particular force there. At that time you can see that the door is connected with the hinges. So around that hinges, the door will make a particular turn, isn't it? And that's an example for this moment of force. So you just consider when you are opening, just consider the case of you are opening a particular door and you are applying a force at the end of the door. Okay, you are applying a particular force on the end of the door, and at the same time you are closing the door, and there the point of action of force is something closer to the hinges. Okay, so in both the cases you applied some force, but definitely you can say that the force you applied on that both cases are different, isn't it? You have to apply more forces in the second case than the first one, which means the lesser force is required only to open the door, but you have to put more effort to close the door if you are applying the force something closer to the hinges, isn't it? So there you can see the line of action or the point of action of force as it moves away from the point of fixed axis or line of axis, then definitely more force is required if it is more closer to the line of action, and less force is required if it is away from the fixed axis, isn't it? Just consider the case of a seesaw. Example for a seesaw. Just consider a boy sitting here having a bigger mass. Just consider a boy is there of, just consider 70 kilogram is sitting here, and another boy is sitting in the other side. He is only of 30 kilogram. Okay? And even that 30 kilogram boy can make this seesaw in an equilibrium state, in a steady state, if he sat in this particular seesaw far distance away from the center, isn't it? You are experienced this type of things. How is it possible? There we are applying a particular force here. This is the force acting here because gravitational force will be there, and the line of action will be this one. And even that line of action and this force can make a particular turn around this fixed axis, isn't it? Fulcrum we are telling. So around that particular fulcrum, the body will make a turn, and that is the principle comes here in the moment of force concept. In order to rotate a body around a point or a fixed axis, you have to apply a force, and such that the line of action of the force does not pass through the fixed point or line of axis. So you just keep in mind here, you can see the line of action is not passing through the fixed point or the line passing through the axis. So it is not in that manner. So you can say that in order to rotate a body around a point or a fixed axis, you have to apply a force, and the line of action of the force does not pass through the point or the axis. That one. Clear? So as I said earlier, moment of force is a turning effect of the force happening on that particular body on the application of the external force. Clear? Okay. Then come to the case of this moment of force. What are the factors on which this moment of force is depending? So basically you can see that the force, if you apply more force here, then definitely the turning effect will be more. Just consider the case of the door itself. Okay, you are applying 20 Newton force and 30 Newton force at the same point of action in the case of a door from the same distance from the hinges. Then you can see when you apply more force, more will be the turning taking place on the door, isn't it? Isn't it? So that manner we can say force. If the applied force is more, then definitely turning effect will be more, or moment of force will be more there. Then the second one is the perpendicular distance of separation between the turning point and the point of action of force. Clear? Here, just consider this case. This is our turning point. So around this particular fulcrum point, the seesaw will make a turn, and this is our point of action. If the distance between these 2 points are more, then definitely the turning will be more there, isn't it? So that's why you are feeling you have to apply more force when you are closing or when you are opening the door, putting the force of point of action something closer to the hinges. There you have to apply more force there because the distance of separation is very small. So as the distance decreases, you have to apply more force there. Okay. So if you apply more, if you are applying the force at a point far away from the point of action, turning point, then the moment of force will be more. So these are the two the perpendicular distance. Okay. Distance between the turning point and the point of action of force. So these are the two factors on which the moment of force is depending. So if more the force, more will be the moment of force, or more the distance of separation, then definitely more will be the moment of force. So we are representing moment of force by the letter tau, which is equal to the product of force and the perpendicular distance of separation. Clear? So this is the mathematical expression for finding the moment of force taking place on a particular body around a fixed point or axis. So that will be torque is equal to force into force times the perpendicular distance of separation between the turning point and the point of action of force. So more the distance, then more will be the turning, or more the force, more will be the turning effect. Or turning effect taking place on that particular body around the point of turning or point of axis. Clear? Okay, so we can see the case of a rigid body. Just consider we have a rigid body something like this. Okay, we are applying a force at the point P, and let's consider. Just consider this be the point in which the body is pivoted, and we are applying a force here. So as we have discussed, the point of action of the body will be this one P. And what is that point of action? The previous section we have discussed the point at which the external force is acting. Let's consider force of F is acting here. Okay. Then we can consider the line of action of force in this direction. Okay. According to moment of force, if you want to find the total moment of force taking place on this particular body around this turning point, then definitely you have to use this term, that mathematical term, that is torque is equal to force into the perpendicular distance. So here, this is the line of action of force, and this is our center, the point of axis or through which the body is rotating. So the perpendicular distance, you can consider the perpendicular distance between the line of action of force and our turning point. Clear? Or the axis through which the body is rotating. Clear? So in that manner we can say the torque acting on this particular body will be the product of force and the perpendicular distance, that is of P. Clear? So in this manner we can calculate the moment of force or the turning effect taking place on that particular body with respect to the external force. And what will be the unit of this moment of force? You can see this is force and this is distance, so the unit will be Newton meter. So this is the unit, SI unit for torque or moment of force, that is Newton meter. Clear? So that's about moment of force. So moment of force is a turning effect of the external applied force on the body about that particular turning point. Clear? So it can be found with using the mathematical expression torque is equal to force into perpendicular distance. So two factors are there on which the moment of force is depending. First one is the force acting, and the second one is the perpendicular distance between the turning point and the point of action of forces. Clear? So this is about moment of force. So thank you.